So good evening students. So in this session we will talk about cryptography. So first of all we need to understand what is cryptography and why do we use it. Okay. So cryptography, this comes from two words. First is crypt. So let me write. This comes from two words, that is crypt and then we have graphy. Okay. Crypt and graphy. So crypt means is something related to hide or keep it secret. Or we can say. And this one is to write or something. It means that, let's say we talk about our social security, or when we are surfing internet, right? Or maybe we are sending some file, right? Let's say, first of all, let me explain you how this communication system works. Let's say you are searching some product on Amazon.in, okay? So what you are doing is, let's say you are the user A, and first of all, in your system you are searching Amazon.in, okay? Or you are searching for any product. So what happens is, from here, whatever the packet you are sending, the in form of data, so first of all it goes to the public network, and that is called the internet, right? And from the internet it goes to the Amazon.in server, right? But the only thing is, when you are sending some data, or when you are querying, or when you are searching for some product, then the thing is, whatever the information you are sending over the internet, is it secure or not? This is the main important thing, right? I'll put this into simple word also. But first of all, we need to understand how we connect one computer to another computer. Let's say this is Amazon.in, so they have a big server, right? First of all, tell me what is server. You know, what do you mean by server? Server is nothing but, we can say, big CPU, right? So we have CPU, right? So Amazon.in is having a big server. So we can say like they have distributed server. Distributed server means, let's say we are in Coimbatore, so they have server in Coimbatore also. And let's say we want to search some information. So what happens? So in this server, lots of information is there. So when I am querying something, so internet will connect me to the nearest server, right? So that I can fetch the information as soon as possible. So similarly, what happens when I am sending some information to the internet, there will be some hackers, right? There will be some hackers, or we can say there will be some attackers. And what their aim is to steal the information. Or you can say, let's say you are doing some transaction. Let's say some bank is there. Let's say you can say some ABC bank is there. And the thing is, you want to perform some transaction. And corresponding to transaction, there will be OTP, right? And what if you are depositing your doing some transaction, there will be OTP. What if some hackers comes and get your OTP? Then he can do whatever he wants to do with your account, right? It means that the data you are sending over the internet, it has to be encrypted, right? If you are sending the plain text, any third party can access it and then they can modify it, right? So that's why we need the cryptography. It means that whenever we are sending any information over the internet, first of all, what we'll do, we encrypt the data and then we. Okay, so as we were discussing, what we need is cryptography means what? To hide, or crypt means we can say to hide or secret, and graphy means simple writing. It means that when we are talking about the internet security, so whatever the packet or whatever the data we are sending, so that has to be secure. So let me put this into simple words. Let's say this is A, let's say this is someone A, and there is a B. And let's say we have only two computers, and A wants to send some message to B. Okay, the thing is, let's say that any message, let's say A is having a simple plain text that is good. A wants to send that message to B, and what is between A and B? There is a network, right? And that is called the internet. And internet is not owned by someone else. Internet is a public property. Anyone can access the internet, right? So what we do is, let's say there is some third person C, and let's say A is sending that packet to B, and let's say A has not put any code to good. So it means this message A is trying to send to B. Now what C can do, C we can consider as an attacker or third party. C can access that message, right? So it means we want the message A that is sending to B, that has to be secret, right? Only A can read and B can read. Now here C has access because we are not encrypting this first thing. That's why we need the security. Or let's say we can say, let's say A is some organization and B is having some interview scheduled, and they are telling, let's say A is sending a message. Let's say you have some interview or some at 5:30 p.m. And let's say C can access that interview. Okay, C can access that code. Then what C will do? C can modify also, right? If C have got that message, what C will do? Instead of 5:30, C can make 6:30 also. Then what B will receive? B will receive that I am being invited from company A at 6:30. Then by the time B reaches to company A 6:30, interview will be over, right? It means that whatever the information that company A or organization A is sending to B, that has to be confidential, right? And we want that no, apart from A and B, third party cannot access it, right? It means that what we want whenever we are talking about the internet security, we want our data to be confidential, right? It has to either A can read it or B can read it, right? And the third thing is, let's say C has the access, but this time what will I do? Instead of simply sending A to B corresponding to G, let's say I'll write that. What is the rank of G? 7. Here 15, 15, and D is the 4. So instead of sending the simple message, I will encrypt this. This is the primary level encryption. We'll read more about it. It means that G I am writing as 7. Then this message, if I send over the internet, and if C sees it, if C has the access of it, then also he cannot decrypt it, right? Because he don't know the logic, right? How we have encrypted our original message into this. It means that cryptography is required for confidential. Let's say A is some bank, he's doing some transaction to the bank B, and let's say C got all the information. The C can do whatever he wants to do, right? It means that cryptography is nothing but a art of protecting our data from hackers. Simple, right? Yes. Yeah, actually cryptography is a part of cryptography we do in our internet security only, blockchain also, all these things work on cryptography only. But here we are focusing on the logic part. Whenever you are doing some blockchain, right, you heard about it, blockchain, cryptography, all these things. So cryptography is means we are providing the security to our data. You can understand, like we are sending some data A to B over the internet. Lots of hackers are there. We can say, like sometimes you heard, like you are downloading some file, some unwanted files get downloaded in your system, and that can corrupt your system, right?
It means that we want to ensure when you are sending some data, right? When you are doing some transaction, you have you seen this HTTP and all? When you start go through a website, they tell this website is secure, this is not secure. So secure means what? They have used some encryption. So that's what we are talking about. So encryption, they use coding. So using that coding, what they do, they protect our file or they lock the file, and that is called the primary key. Let's say I'm sending this message. So first of all, what will I do? That message, let's say this is the simple message I want to send. First of all, using the encryption. So encryption, this is where the coding parts take place. So they use some code, maybe some Python or C programming or Java, whatever the language. After then they convert this message into a code, coded message, and that is called the ciphertext. This is the name given. Then they convert into the ciphertext. Clear? So what happens in this ciphertext is not, this is the coded file, right? This is the coded file. So even any hackers or third party has access of it also, they cannot open it, right? Because this is in non-readable format and this is in readable format. So what they do is they convert that before they send to the receiver, they encrypt it. This ciphertext goes to the internet. Then this message goes to the B. So before it reaches to B, they use some system that is called a decrypt. Decrypt means what? Converting this coded message into original message. Now B can access that information. So what happens to provide the security? What we do is, first of all, we get the message. Using some code and using some algorithm, we convert into a coded language, and coded language is called a ciphertext. The ciphertext goes over the internet. Now no one can read this. They can see the message, but they cannot understand what's there, right? After then this goes to the decryptor. Decrypt convert that confidential message, or we can say ciphertext, into the normal message so that we can read it. Is it clear? So what is cryptography? Cryptography is nothing but the art of protecting our data by transforming into the ciphertext. So ciphertext means we are using some algorithm so that the normal message which we are using, so that we can convert that message into, yes, come in, so that we can convert that message into non-readable format, right? So this we can read only when we use some decrypt. It means, let's say A node what is the logic we are using, and B also know the what is the logic we are, then only A can read it and B can read it. So it means we are transferring data A to B over the internet, but not A and not B. They cannot have access of it, right? Sorry, A and B can have access of it. Over the internet also they can see, but they cannot understand what is there, right? Let's say C wants to destroy this file, he can do it. But let's say C wants to access, or C wants to see what is there in this file, he cannot do, right? So that's why we use the cryptography. Now there are so many algorithms there. Like we can do this, like we are using this G7151. This is very easy, right? Everyone can understand after going through this G7. Then what they can do, they can decrypt and they can find the original message. Now we'll talk about what are the various types of algorithm they use in cryptography. Okay, actually we'll focus on logic part only. I'm just giving you the idea what is cryptography and how do they use it. Cryptography means let's say you are sending some message directly to another one, or let's say you can say some postman. If you directly send a message, even postman can open the letter and he can read it. But once you code that message, on you tell the code to your receiver, then postman can't do anything because that coded language is there, right? He cannot understand, right? It's not the simple English text. It means we are using some code. Likewise, you use some code and give to the postman. Even if he opens it, he cannot understand, right? The same thing we are applying here. So when we are sending a text to A to B, then what is happening? We are, before sending directly, if we send directly, C can access it, right? But before sending directly, we are using the encryptor. Encryptor means we are converting our normal message into the coded language, and that is called the ciphertext. Before it reaches to B, there is a program in the system of B that is having decryptor. It means that B, first of all, that message ciphertext will go to the decryptor. Now this decryptor, what he will do, ciphertext into normal message. The normal message B will receive, right? It means we are passing information over internet and it is secure also. Clear? Okay. Next you see what are the encryption method they use. First of all, mostly RSA encryption. Actually, we won't go into that detail. I'll just give you the idea. when you use WhatsApp, you see like your messages are secured or encrypted end to end. What is meaning of end to end? End to end means, let's say you are typing some message to your friend, it means you can read that message. Then WhatsApp is having some algorithm, so what they use this RSA encryption. So what they use is, so they convert your message into the ciphertext. The ciphertext goes to the Amazon, the Facebook or WhatsApp server. Then server 2, it goes directly to your friend's mobile. So there they are having what? They are having the decryptor. Then that convert into the normal message. So RSA encryption works on the principle of prime numbers. So all of you know what is prime numbers? Any natural number which is divisible by 1 or itself, or we can say that has only two factors. So if I ask you, let's say we can multiply two numbers easily, right? Multiplication of prime numbers is easy. So we can say 1147. But RSA encryption works on the this principle that they find the, they give you a prime number, product of prime number. But if I ask you, can you factorize 1147? It is little difficult because it is not divisible by 2, it is not divisible by 3, not divisible by 5, because it means that this RSA encryption works on the principle of prime factorization. Okay, so what happens is in RSA encryption, what they are doing is, so let's say I'm sending some message. So that message I'm using some code. So this message will open only when I use some code. So that code they are using something like this 1147. It means that they can say this is, let's say their actual code is 3137. That you will understand only when you can factorize this. This is just a small number. Let's see if I give you another number. Let's say 414 863. Let's say this is some number. Now this is nothing but the product of two prime numbers. So now can you find those prime numbers? Very difficult, right? So RSA, we are not going into that detail. I'm just giving you an idea. Facebook, WhatsApp works on this concept, RSA encryption. What they do is they multiply two prime numbers, big prime numbers. How many prime numbers are there? Infinite prime numbers. So similarly, they take any random two prime numbers, multiply them, they get this number. So this is not the actual code. If they give you this code, any hacker can type them. What they do is, let's say this one is nothing but 719 into 577. So what is the actual code? Actual code is 719577. Now from here, can you reach this? It will take lots of time, because if you try to divide by 2, it won't divide, because prime number is not, it is not divisible by 2, 3, 4, 5. By the time you reach 719, it will take lots of time, right? By the time this hacker or third party will get tired, we are not trying. This is just a small number. You think if you take some 10,000 digit prime number, again 10,000 digit, and then you multiply. See? So that's how you cannot access this. So this is first one, RSA encryption. So here concept used is they multiply any two prime numbers, and that product they give, that is they use as a key, and from the key they know how to access the actual code. Actual code is 719577. So once they put this code, this file will open, and this file will convert into readable form, right? So this work, RSA works on this product of a prime numbers. Okay. Next we see that is CSAR encryption. CSAR encryption. Here what they do is, actually this is the primary level of encryption used at the time of World War and all, right? When just internet just started. So that time also they were supposed to transfer some information from one place to another place. So what they used to do is, let's say some H is there. So for, let's say I have to transfer some message H. So for this H, they used to some code. Let's say instead of H, I can use some letter O. Instead of I can use some letter K. So actually within the army, let's say some army is there, in that they knew how that letter will be coded. Then that moment someone is sending message to someone, so they have already the code, they have that message they will send, they know O is coded as H, they will put H. So it means that English alphabet, one alphabet they are coding into another alphabet. It's not ki H will be coded as O, H can be coded as A also, but they have the set of list. This is very primary level of encryption. It means they are using some basic keywords. Okay, this is CSR encryption. Okay, next we have that is monoalphabetic. Monoalphabetic. Actually, no need to remember this. I'm just giving you the idea how encryption system works. Monoalphabetic encryption means what they are doing is, let's say some word is there. So for A they can use some Q, for P they can use some N, this one they can use some R. Okay, and here in CSAR encryption they can do this thing also. Let's say HI is there, so the H they can add 3. H is 8 plus 3, this will come K. I is 9 plus 3 L. So it means they know what the coding. This is a very primary level of coding, because here anyone can identify. It means what is happening, they can identify the logic, but this is the primary level of encryption. Here what they are doing is, here mono alphabetic, here instead of a they can use Q also, instead of E they can use the A also. It means whatever the message, or whatever the message available in the, whatever the letter available in the original message, that letter also they can use. Let's say A is available, so that letter also they can use. So this is called the mono alphabetic. Yeah, they can assign it, but before they have set of rules, that rules are available with the sender as well as the receiver, so they can easily decode this, right? Next we have, that is homophonic. So homophonic is next one. Homophonic encryption. In homophonic encryption what happens is, actually this is the advanced version of this. Here what we are using, whatever the letter available in the original message, that also we can use as the original code. Here original message, the letter of original message won't be used as the code language. It means A has been used. It means whatever letter we are assigning, so A we cannot use as a code language. So there are three types of encryption. RSA encryption used for, it is the product of two prime numbers. And CSAR encryption means we can add some number, or we can shift the number by +3, +4, whatever. Mono alphabetic means like we can assigning some code, and here some change is there. Let's say A has been used, so we cannot give any of the letter code A, right? Yeah. Oh, see, like this is the very primary. They try different methods. Maybe they tried added +3, +2. Or here it means they have set of rules. Like A we code as a Q, P will code as a N. Here this is the very primary level of coding. They tried something. Let's say HI. Then let's say they had some key CO. Let's say CO is our key. What is the rank of C? 3. So H they added 3. So it means this will come K. What is the rank of O? That is 15. So I is what? I is 9. 9 plus 15, 24. 24 is what? KX. So now whenever we are sending message, we'll just send the key only, because here we are adding 3. From here we'll subtract 3, will get the H. So in CSAR encryption, they tried lots of algorithm, like which one should work, which one should not work, and which one is more confidential and which one is more secure. Here they had some set of rules, like A will encrypt as a Q. There are no. P will encrypt as a N, something like that. And here what happens is, lots of alphabet started matching. When let's say when you are writing a message, so A will repeat, so your alphabet will get over. So sometimes let's say you have used A as Q, so in original message Q should not appear. If Q is appearing, then your key or code language both are mismatching. So that's what they moved to the homophonic encryption. Here they have made the rules, whatever the letter we have used in original message, the same letter we won't use for the code. Clear? Okay, this is the basic part. Now we will move to the mathematical portion. Actually, this is just giving you the idea what is the cryptography. Now here we'll study about the mathematics behind the cryptography, like what is the method we are using. Okay. So cryptography simply means we want to protect our data. So to protect the data, we'll use some code, we use some set of rules, so that I can understand that code, but no one else can understand that. Simple. So now you see, so before we go, let's talk about this modulo operator. Then we'll move to this. Just a minute. So first of all, we'll see. If I ask you, let's say there is a number 5, or let's say 7. If you divide it by 2, then what is the remainder? 1. So this is 1 times. So 2 times. This is 6 and 1. 3 times. This will be 1, right? So this 1 is called the remainder. This 2 is called the divisor, and this one is called divided. This is quotient. So 7, can I write it this format? 2 times 3 plus 1. So this one you already studied. This is one way of writing the information. Another way which we will be using, so I can write A, let's say you have three numbers. Let's say B, you are dividing by A. Let's say some Q is coming and some remainder is there. So can I write B is equal to A times Q plus R? Right? So this is one way of writing the info. Another one we use, that is modulo operator. So now we will understand what is the modulo operator. So we know if I say the addition operator, what it does? Addition operator is nothing but it adds two numbers. Similar way we have modulo operator. What it does is, let's say you have some number here. Let's say here, by what number we are dividing A, and here we have B. So what it will tell is, when we divide A by B, then what is the remainder? It means when I am dividing B by A, then what is the remainder? R. Similar way, if I ask you here 5 is there and I have mod 3, it means, so this is another way of writing the same information. It means when I am dividing 5 by 3, then what is the remainder? 2. So here 2 will come. Clear? So this is called the modulo operator. Is it clear? So how do we write MOD? Actually, after this, we'll study about Chinese remainder theorem. So for that purpose, I need this basics. So that's why I'm asking. 5 mod 3 means 2. Clear? So let's say if I write next thing, 3. Okay, if I ask you 3 mod 7, what is 3 mod 7? So it means it is asking when I divide 7 by 3. We say 7 we cannot divide by 3. So here remainder will be 3 only. Are you getting my point? You see, how can I write 7? 7, how can I write? 8, sorry, how can I write 3? Because here, first of all, from here, you tell me which one is divisor, which one is divisor here? 7. Which one is dividend? 3. So in number theory, whatever happen, whenever my dividend is less than, then the division, then remainder will be this one only, right? Let's say, so this time 3 is my dividend, right? So 3, how can I write in terms of 7? Can I write something like this? 0 times 7 plus 3. Clear? So next you see, let's say we have 10 mod 4. What is 10 mod 4? Anyone? 2, right? It means this one is nothing but dividend. This one is nothing but divisor. So what will the answer? 2. Okay. Let's one more. Let's say you can do minus 3 mod 7. What should be the answer? All of you try. No. All of you know remainder can never be negative. So what do we do when we get the negative remainder? No. Okay, I'll give you some method. So I can say, first of all, let me give this one example. So I'll say A mod n is equal to R. So first of all, tell me what is n. N has to be, n will always be a natural number, right? Because we always divide by a positive number, natural number. Next, tell me what is A. I can say A can be any number, right? A can be either negative integer or positive integer, because here you see positive we are using, here we are using negative. Next, you talk about R. What is the R? R is the remainder. So can I say R not positive? I can use 0 also, right? It means R has to be whole number. It means there is 3 possibilities. Only this number can be negative. Other number, this number has to be positive. This number cannot be 0 because we cannot divide by 0. Can R be 0? Yes, definitely it can be 0. Let's see if I ask you 10 mod 5. What is the answer? 10 mod, because 10 is divisible by 5. So similar way, when we have negative numbers, so how can we solve this? We'll see. Whenever we have negative numbers, so first of all, what we'll do? It means I have to write minus 3 in terms of 7. So it means I can write minus 3 here. Minus 3 will come. So it means 7 times something and plus here remainder will come. So finally I need what I need. So here what will I do? Minus 1 and 4. But the thing is, I need the remainder positive. I could have written 0 also. 7 into 0 minus 3. Right? So if I can write, because quotient can be negative. We are not worrying about the quotient. The only thing is we need the remainder positive. And the remainder has to be less than 7. Are you getting my point? Let's say if I ask you 11, 3. So definitely the remainder of this one has to be less than 3. Is it clear? Because if remainder is greater than 3, again it will divide. It means that this remainder has to be less than 7. So here what will the remainder? What should come here? 4. Are you able to understand? Whenever we are getting the negative dividend, how we solve it? We divide by, let's solve one more question. Now tell me mod 3. What will the answer of this? Minus 4 mod 3. So again, what I need? Minus 4. So it means that 3 times something plus something. So but the thing is, I need this thing is positive. So what will I do? If I put minus 1, then again minus 1 will come. If I put minus 2, then it is correct, because 3 to the minus 6. Then minus 6, what should I add so that I can get minus 4? 2. So what should come here? 2. Is it clear? Can you handle the negative remainder case when this dividend is negative? Because this thing will be using that Chinese remainder theorem. So I'm just giving you the basic idea. All of you understood what is the modulo operator? This n is nothing but the divisor. This a is dividend, and this r is nothing but remainder. Now tell me, this one is clear, dividend, mode and divisor, and r is the remainder, right? But can this be negative? Yes, this can be negative and this can be positive also. Now tell me, can this be negative? Not at all possible. Can this be 0? Yes, remainder can be 0 and it can take all positive values. It is clear. So hopefully this modulo operator is clear. Basic understanding you have got it. Now I'll explain some of the properties. Okay, last one. Okay, try this one. 11 mod 3. What should be the answer of this? Minus negative 11 mod 3. All of you try. Negative 11 mod 3. What should be the answer? Negative 11 mod 3. Negative 11 mod 3. One. Yes? Clear? You see, how do we do this? Minus 11 equal to 3 times something plus 3. So here what will have come? Minus 4. So minus 4 3 is 12. So here what will happen? 1. Is it clear? Okay. Next you see, that is, now we'll see some of the properties of the, it means we can say, we'll tell ki two integers are called a congruent. You see, in sometimes we use equal sign. This stands for equal sign. Sometimes we use 3 signs. This sign is used for congruent. Why do we use for congruent? Because you see, when I'm adding some number, 2 plus 3 equal to 5. But here what happens? There are more possibilities, because you see, when I'm dividing, let's say 5 mod 3. So what is the remainder? What is the answer of this one? 2. 2, right? Similar way, if I divide, let's say 12 mod 5. So what is the remainder? 2. But this time we use the congruent. Is it clear? So whenever we get this, whenever two integers, is, you see, this number is also giving the remainder 2. This number is also giving the remainder 2. It means that, but there are so many numbers. You see, how many numbers are there when divided by 3? Sorry, when 5 divided by 3. But if I add 5 also, 5 plus 3, 8. 8 also will give remainder 3. It means this side will have set of numbers, this side will have set of numbers, but both numbers won't be equal. Are you getting my point? It means that here we use this 3 bar sign, and this bar sign is called the congruent. It means, when do we call two numbers congruent? When both leave the same remainder. So we'll say, first of all, I'll say a mod n. It means here I am talking about the a, here I am talking about the b. If two numbers leave the same remainder when divided by a number, then both numbers are called the congruent. Is it clear? N divided by a, let's say answer is some 5. And b divided by n, let's say answer is some 5. So both numbers are called the congruent. But from here we can say, it doesn't mean a has to be equal to b. Is it necessary that a equal to b? Not necessary. Here also you see, I can use something, let's say 5 mod 3. What is the answer? 2. But let's say I can say 8 mod 3. What is the answer? 2. Is it necessary 5 and 8 are equal? Because there are more numbers which can leave the same remainder. So when can we say that both numbers, when two numbers are congruent, it means that a mod n congruent to b mod n. So in simple words, we can say both must leave the same remainder. Is it clear? What? Yeah, this n has to be same. Then only it means corresponding to the same number, because they both number has to be same, right? So corresponding to the same number, If both numbers are leaving the same remainder, then both numbers are called the congruent. First one is clear. Okay, next you see, next I'll call, let's say A is congruent to B mod n. A is congruent to B mod n. So here we don't say equal sign. Here we say A is congruent to B mod n. Next we say B is congruent to C mod n. So if I combine these two, A is congruent to B mod n, B is congruent to C mod n. So from here I can say A is congruent to C mod n. Actually we are using this property. A is congruent to B mod n, B is congruent to C mod n. So that's why A is also congruent to C mod n. Clear? These are some of the basic properties. Actually, we won't be using all the properties. I'm just telling whichever the property will be using. Okay. This one is clear. So next we'll move to the Chinese remainder theorem. So next we'll move to the Chinese remainder. Just a minute. So what happens in Chinese remainder theorem? So they are telling that you have to find, let's say I have some number x. Okay, I have some number x. So first of all, I am telling why do we need the Chinese remainder theorem and how we can solve it. Let's say you have number x and you are dividing it by 5 and you are getting some remainder that is, let's say 3. Clear? Let's say you have another number, same number, but this time you are dividing by 2 and let's say remainder is 1, for example. Let's say you have the same number, but you are dividing by 7 and remainder is, let's say, 5. And let's say you have same number, you are dividing by 11 and you are getting 4. Now the thing is, how can we solve this for x? Are you getting my point? We have a number, when divided by 5, remainder is 3. When divided by 2, remainder is 1. When divided by 7, remainder is 5. When divided by 11, remainder is 4. The thing is, we have to solve for the value of x. Is it clear? So this is where we'll use the Chinese remainder theorem, because here also you can say, sir, we can use some number theory concept also. But you see here, as the number of equation increases, it will become lots of very complex, right? Here, how many equations I have? 4 equations. I can make 7 equations, 10 equations also. Then it will be very difficult. So now we learn how we can use the Chinese remainder theorem. Is it clear? Just a minute. Yes. It's on only. That which one? That one I don't know. You try this. Actually, I have only one remote. Okay, you see here. Now we learn what is the Chinese remainder theorem. So first of all, let me give you the statement. So when do we use the Chinese remainder theorem? It means whenever we are given a number and that number we are dividing by different prime numbers, and now they are asking what is that number. So first of all, let's say you have number x is congruent to a1 mod m1. So can anyone explain what is the meaning of this? It means x dividing m1 by a1 by m1. Next one, I can say same x I am getting a2 mod m2. Clear? It means, or you can say something like this also. You see, this holds vice versa. This one, what you are doing is m1 you are dividing by, sorry, a1 you are dividing by m1, and this one is remainder. First one. Another one you can say x you are dividing by m1 and you are getting remainder this. Either way you can say, because sometimes we are getting negative. Let's say if I ask you what is the answer of this, 2, right? Answer is 2, because this one you are dividing by 2. But here you can write, let's say here you are getting 3, and let's say you write 70. This one you write, then also it is correct. What happen is, we can consider it vice versa. Here what I am doing is, here I am considering this as a, when I am dividing a1 by m1, then I am getting x. This time x has to be less than m1, right? But if I do this thing, here I am considering when I am dividing this number by m1, then this is working as a remainder. It means this one and this one we can interchange. You can see this one. So let's say if I am asking mod 7, and let's see if I'm writing 5, 15. Then what number should come here? So this time we'll say 15 divided by 7. What will the remainder? 1. So this one also we can consider. So mode, because mode operator we have some advantage, because here we are writing something like this, bq plus r. So what we can do is, instead of q we can put q plus 1 also, because q is nothing but the quotient. So we can increase and decrease, and we can interchange this r and a. Is it clear? So it means that what is x? X is congruent to a1 mod m1. So here we are considering when x is divided by m1, then remainder is a1, right? So let's say we have some set of equations, a3 mod m3, and likewise let's say we have n equations, but here we'll be doing for only 2 or 3 equations. So here we have an mod mn. It means that m1, m2, m3, and all numbers are my prime numbers. Is it clear? All numbers are my prime numbers. It means I am dividing the same x by prime numbers, that is m1, m2, m3. It means, and corresponding remainder is a1, a2, a3. So if I write this into simple words, I can say x I am dividing by m1. So I can write x is nothing but m1 times some quotient plus a1. Is it clear now? Clear, right? Now the only thing is how we can find the value of x. So for this we have formula, that is x is congruent to, first I'll write a1. A1 will be given in the question. Then we have m1. I'll explain what is capital M1. Then m1 inverse, that I'll explain. A2, m2, m2 inverse, and so on. Here we have finally an, capital mn inverse, and then we have mod capital M. So this is the formula we are going to use. But if the question is given in this format, it is little difficult to understand. But first of all, I'll explain this question in little easy way. So first of all of you write the question. Find the least positive integer. First of all, you can write this one. First of all, write this one. Write these 3 1, and then final condition, this one. And but the only condition is, write this condition also, the numbers which we are dividing, which has to be co-prime. All of you know what is the co-prime numbers? What is co-prime number? If I ask you 6 and 7, whether both are co-prime number or not? What is co-prime number? Co-prime number is between 6 and 7, there should be no common divisor except 1. It means, let's say 2 and 3. What is the divisors of 2? 1 and 2. Divisors of 3? 1 and 3. What is the common? 1. It means two numbers are called co-prime number if between those number 1 is the only common divisor. Clear? So similar way we are telling, between m1, m2, m3, whatever the numbers we are writing, all has to be co-prime numbers. Is it clear? So first of all of you write this one, then we'll solve this question. Done? Again turned off. I don't hear the switch. One second, I'll miss. Okay. This one is, everyone has written? This one? After then you see, now all of you write the question. Find the least positive integer. Find the least positive integer which leaves the remainder. Find the least positive integer which leaves the remainder 2, 3, 2 when divided by. Find the least positive integer which leaves the remainder 2, 3, 2, 2, 3, 2 when divided by 3, 5, 7. Clear? Find the least positive integer which leaves the remainder 2, 3, 2 when divided by 3, 5, 7. Now you see how we can solve this. So first of all, I'll write the equations. First of all, you consider it means that when I'm dividing by 3, remainder is 2. Dividing by 5, remainder is 3. Dividing by 7, remainder is 2. Let's consider that number is x. So here from here, can I write dividing by 3, remainder is 2. So can I write something like this? 2 mod 3. Clear? That number dividing by 3, remainder is 2. Next. Next we have x. Dividing by 5, remainder is 3. So dividing by 5, remainder is 3. Next we have dividing by 7, remainder is 2. So far it is clear. So from this one, if I compare from the original equation, that is nothing but a1, a2, a3. These are my a1, a2, a3, and this one is m1, m2, m3. So can I write a1, a2, a3? What is a1? 2, a2 is 3, a3 is 2. Here what is m1, m2, m3? m1 is 3, this is 5, and this one 7. So far clear. So in our formula we had seen capital M1, capital M2, capital M3. Now we'll learn how we can find the capital M1, capital M2, capital M3. So first of all we'll write capital M1, capital M2, capital M3, and here we have seen the capital M also. So capital M is nothing but the product of small m1, small m2, small m3. So what is capital M? Small m1, small m2, small m3. What is the capital M? 3 into 5. So 7 into 5, 35. I think this is 105. Clear? Now we have to find capital M1. So capital M is what? Product of small m1, small m2, small m3. Is it clear? Next is capital M1. Capital M1 is nothing but m upon small m1. So capital, this one you divide 105, you divide by 3. So what will the answer? 35, right? Is it clear? Capital 105 divided by 3 will be 35. Next, this one m up over m2. Or you can say when you are finding m2, it means you divide m1 into m3, because when you are dividing by m2, m1 into m3 will be left. And what is m1 into m3? That is 21. Similarly, if I ask you what is capital M3, 5 3 is 15. So far clear. But in our formula we are left with m1 inverse, m2 inverse, and m3 inverse. Okay. But m1 inverse is nothing but 1. It's not 1 over 35. This is different. So far it is clear. Any doubt? How do you find capital M? Product of this. Capital M1 is capital M over small m1. Now we have this formula. This one is clear. Next, let's see. Now we have m1 into m1 inverse is congruent to 1 mod m1. m1 into m1 inverse. This is what we have to find. So what is value of m1? 35. What is m1 inverse? m1 inverse is what? m1 inverse we have to find 1 mod. What is m1? m1 is 3. It means that we have to select the value of this such that this number, if I divide by 3, my remainder should be 1. Now you check 35 divided by 3. It means here I have to substitute the value of m1 inverse. m1 inverse, if I take 1, so 35 divided by 3, is it the remainder 1? 35 divided by 3, remainder is not 1. Is it clear? It means that from here I have to substitute the different value of this one such that this whole number divided by 3 should leave the remainder 1, right? So first of all I start with 1. If I put 1, then what will come here? 35. 35 divided by 3, is it the remainder 1? No. Then it means 1 is not accepted. Now I'll try m1 inverse is equal to 2. If I take the 2, then left hand side becomes 70. 70 divided by 3, is the remainder 1? It means I'll take the m1 inverse equal to 2. Is it clear? Similar way we'll try for, you see, m2 times m2 inverse congruent to 1 mod m2. What is capital M2? 21. Here we have m2 inverse congruent to 1 mod. What is small m2? 5. Now all of you try. What value should I take? 1. If I take 1, this will be 21. So 21, if I divide by 5, remainder will be 1. It means that what is m2 inverse? 1. Is it clear? Similar way, if I ask you, how can you find m3? m3 into m3 inverse is congruent to 1 mod m3. Sorry, 1 mod is small m3. Now what is capital M3? 15. This will be m3 inverse 1 mod small m3 is 7. Now all of you try. Can I put m3 inverse equal to 1? No. If you put 1, then this will be 15. 15 divided by 7. Will it leave remainder 1? 15 divided by 1? 7. It means 15 divided by 7 will leave the remainder 1. So it means that we have got, what is m31? So we have got all the values. Capital M we have got. M1, M2, M3 we have got. M1 inverse, M2 inverse, everything we have got. So let me write it here. What is capital M? First of all, capital M is 105. What is M1, M2, M3? 35, 15. Now what is M1 inverse, M2 inverse, M3 inverse? 2, 1, 1. So far clear. Now we have to solve for the value of x. What was the formula? X is congruent to A1, right? Formula was A1, M1, M1 inverse. What is A1? 2. What is M1? 35. What is M1 inverse? M1 inverse is 2, right? Plus. Then A2, M2, M2 inverse. What is A2? 3. What is M2? 21. What is M2 inverse? M2 inverse is 1 plus A3, M2. Then we have, A3. If I'm using A3, then M3 will come. What is M3? 15. Then what is M3 inverse? That is 1. And here what will come? Mod. What will come? Mod M. What is capital M? 105. So from here we'll get x is congruent to, let me write the final expression. From here you'll get x is congruent to 157 mod 105. So from here you can say, if you are dividing any number by 105, remainder will definitely be less than 157. Are you getting my point? It means we have to reduce this. It means that there is some extra 105 here. Are you getting my point? It means that from here can I write x is equal to 105 times t plus 157. Are you getting my point? It means that this number divided by this, then this will leave some quotient, then remainder will be there. But we know when I am dividing by 105, remainder cannot be 157. Remainder will be less than 157. So what will happen? X is congruent to 105t. Some 105 I'll take common. After taking 105, what will come here? 52. So can I say this will be my quotient, and what will the remainder? 52, and that is my value of x. Now all of you can check, if you divide that number by 3, remainder will be 2. 52 divided by 3, remainder will be 2. 52 divided by 5, remainder will be, what is happening? Something wrong we have done? Where? Something, I think, maybe in calculation we have done some wrong thing. Calculation maybe, I don't know. Okay, we'll try one more question. So this is the concept you need to know. The thing is, once you get the final number, then you can check with all the numbers. Divide by 3, then this remainder. Divide by 7, this number remainder should be there. This one is here 232. 232. Now all of you try. 232 will come here. Then 232. Then what will happen here? So I think 105. Then we'll get 210 plus some number, right? 210 plus 22 will get 22, right? 22 will get, I think, 210 plus 22. So this will go here, then 22 will come here. Clear? Still wrong. Calculation, all of you check this one. 140, this one is 63, this one is 30. So 140 plus 30 is what? 170? 232, correct? Just check this calculation, this one. And this one is also correct. Maybe something wrong. Okay. You see where we have done wrong. Where? This one 233. Then answer is 23. Now I think it's correct, na? You see, 23 divided by 3. Remainder will be 2. 23 divided by this one, 7 3. This one is correct answer, right? Now I'll give the question. All of you try. This one is clear, right? So this is called the Chinese remainder theorem. So here we can have more than AC, not one. Oh, this is coming. Just a minute. So all of you try this problem. So I'll give one more problem. So let's say that is having just two only. Let's say we can solve this problem. You see here, let's say you have this one, x is congruent to 1 mod 2. X is congruent. All of you write this problem. Next problem, x is congruent to 1 mod 2. It means that this number I am dividing by 2, remainder is 1. Next one, I am having x is congruent to 2 mod 3. Next one I have, that is 1 mod 5. This time I am having 4 equations, so this will be little lengthy. So all of you try 1 mod 7. Now first step, what will you do? You will find a1, a2, a3, a4. What is a1, a2, a3, a4, right? So first step, a1, a2, a3, a4. What is the value of a1? Can I write 1, 2, 1, 1? Is it clear? Next step. Next step, we have to write the value of m1, m2, m3 and m4. What is the value of m1? 2, right? And this one 3, 5 and 7. So here you can check all numbers are co-prime numbers. Can you see? 2, 3, 5, 7. All numbers are co-prime numbers, right? 71, right? So actually there is some method, like you can use number theory also. Let's say if I have 10 equations, then taking the LCM will take. I know there is one more method that you can take the LCM and you can do this. But actually this Chinese remainder theorem used in cryptography, because what they do is in cryptography they get the big prime numbers, then they do this calculation. Then manually it is very difficult. So to teach the concept, I am using the small values. We can start with like some big number also, right? So just to teach this Chinese remainder theorem, I am doing this one. And actually this in calculation and all we are doing now, this one we can do with the help of Python coding. Let's say you want to find some 2 power 99, so you can use this as 2 power 9, so this will give 2 power 9. So I'm telling like which theorem or which algorithm we use. So in cryptography they use Chinese remainder theorem, so I'm just telling how it works. And when you, here we are using the small numbers, so we can use it here. But let's say we have some 10 equations, 20 equations, 50 equations, like this. Because cryptography means we want to make it more complex so that hackers cannot access the information, right? So that's why we use this cryptography. Clear? So from here we can easily understand, like we can pick any random number. Okay, this one is not working, and taking another number, maybe some LCM method can work, right? But the thing is, that's why I'm teaching how it can work. Because if we start doing calculation, it will take lots of time. So that's why I'm taking simple example. So with this, all of you try. What is the value of capital M? Inverse, I'll explain. What is the capital M? First of all, tell me. This one is 210. Okay. So all of you try to understand this theorem, then we'll learn. This one is clear. Now, capital M1, 105. Very good. Capital M2, 17. 17? 70. Capital M3, 40. You have to, you see, M3, you have to, yeah, 42. M4, 30. Okay. Now we'll find M1 inverse. Let's see how do you find. M1 times M1 inverse is congruent to 1 mod M1. You see, what is capital M1? 105 into what is M1 inverse? Then we have 1 mod. What is small M1? That is 2. Now you see, I want to put the such value of this one M1 inverse such that if this number, left hand side number, if I divide by 2, remainder should be 1. What number should I take? If I take, I will start with 1. If I take 105 divided by 2, will it leave remainder 1? Definitely. Then I'll take M1 equals to 1. Clear? Next, move to M2 times M2 inverse is congruent to 1 mod M2. What is capital M2? Capital M2 is 70 times M2 inverse is congruent to 1 mod M2 is 3. Now all of you see, this one, can I, first of all, I start with 1 only. If it works, okay, then I'll move to the 2. So this is how they apply the for loop and while loop in Python and all. If you have studied Python and all, so what they do, they check for the one condition. If it's working, then apply this next condition. If it's not working, apply. So they run the loop the thousand of time. Then again the condition is satisfied, then they works. So this is how our program works. Okay. So that's why I'm telling this CRT and all they use in the coding. So I'm just telling which logic they are using. Okay. So that's why I'm taking simple number. If we start multiplying big number, it is very difficult. Manually we can't do, right? You see this one. So M2 inverse, can I say it will be 1? Now all of you try for M3. M3 times M3 inverse. So here 1 mod M3. First of all, what is capital M3? 42. 42 times M3 inverse 1 mod. What is M3? 5. Now you see 42 if I divide by 5, will I get remainder 1? No. So it means 1 is not possible. Then I will start with 2. If I take 2, will it work? If I take 2 here, then what will be 84? It won't work. Now I'll take 3. M3 1 inverse equal to 3. If I take 3, it will work. Definitely it will work. Because 6. If I take 3, then what will happen? 126, right? 126 divided by 5 leaves the remainder 1. Similarly, tell me the value of M4 inverse. Find the value of M4 inverse. All of you try this one. M4 inverse. Try for M4 inverse. Then we'll put the values here. M4 inverse, all of you try, you should get answer as 4. M4 inverse, all of you try, you should get 4. What you do, you always start with 1. If 1 works, perfect. Then you move to 2, then 3, then 4. So now let's move to the okay. Now let's move to the x. How do you find x? That is a1 capital M1 M1 inverse. So I'm directly writing a1 is 1. This is 105. M1 inverse is 1. Is it clear? A1 capital M1 capital M1 inverse. Now A2. What is A2 here? 2. What is M2? Capital M2. Capital M2 is 70. And what is capital M2 inverse? 1. Then this will be 1 into 42 into 3. All of you check. This is A1 capital M1 M1 inverse. A2 capital M2 M2 inverse. So now let's last one. What is A4? 1. M4? M4 is just 7. 30. M4 inverse? 4. Then outside what we write? Mod capital M. What is capital M? 210. All of you try to add all these things. So from here you will get 491. All of you try 491 mod 210, right? So it means I can write, or you can say when you divide 491 by 2110, then what is the remainder? Other words, you can say like this also. 491 divided by 2110. What will be the remainder? I think remainder will be 71. Nitya Shri, is it clear? Pardeep? Pardeep, clear?
Yes, sir.
Okay. So from here we got x is equal to 71. So this way we can apply. In your assignment also you'll get some problem where you can apply the Chinese remainder theorem. Clear? Yes. Last step I explain. Last step is you have to, I told you now, if this number is less than this one, then this one is considered the dividend. If this number is greater than this one, then this is considered the remainder. So if I ask you two things, I'll ask you. Let's say if I ask you 3 mod 9. Now what should be the answer? What will the answer? 3 only. Clear? Okay. If I ask you 51 mod 2. Now what will be the answer? 51 divided by 2. What is the remainder? 1. So this will be 1. So similar way we see 491 is greater than 210. It means 491 divided by 210. What will the remainder? 71. So that is our answer. I am telling this is not the only number. This is the least number, right? There are lots of number which divided by this one satisfy this property. It means 75, 71 is the least number. Is it clear? Let's move to the next problem. Next problem is, let's write the next problem. Find the least integer. I'm telling when this problem will fail. Actually, cryptography, we are not given the problem. We are forming the problem, because in cryptography, we know we have to take all the co-prime number. Then only we are doing the problem. But you can ask, sir, what if these are not the prime numbers? We can ask the questions, right? Instead of 2, 3, 5, 7, what if these are not the co-prime number? Then what will you do? So that question will take. Write the question. Find the least number, because this will work only when these are the co-prime numbers, right? But what if these are not the co-prime numbers? Here we can have 2 and 4, then this theorem won't work. Clear? But you can answer, then Chinese remainder theorem will fail. Yeah, definitely it will fail. But the purpose of Chinese remainder theorem is not to solve the number theory problems, right? It is designed to solve the cryptography problem. They have to design the code, right? They have to design the key. So for the key, they are taking the number such that it is becomes very complex for third party to access the key, right? So that's why intentionally they will take this key as the prime numbers. Is it clear? Okay. Next question you write. Find the least number. All of you write. Find the least number when divided by 35, 56, and 91. When find the least number when divided by 35, 56, and 91 leaves the same remainder 7. Find the least number when divided by 35, 56, 91 leaves the same remainder. Leaves the same remainder 7 in each case. Let me explain the question. Question is something like this. Let's say you are having some number x. You divide it by 35. Remainder is, I am just writing the remainder. Remainder is 7. Similarly, same number you are dividing by 56. You are getting the remainder as 7. Same number you are dividing by 91. You are getting the remainder as 7. Now the thing is, how can I find the value of x? Yeah, numbers are 35, 56, and 91. Find the least number when divided by 35, 56, and 91 leaves the same remainder, right? You see remainder is same. So now all of you, here you cannot apply the CRT. Why? Because you see 35 and 56. Are these co-prime numbers? No. Because apart from 1, this 35 is divisible by 7. And this is also divisible by 7. It means these two numbers are not co-prime. Similarly, here you see 56 and 91. Not co-prime number. 56 is divisible by 7. At the same time, this is also divisible by 7. It means here we cannot apply the CRT theorem. Is it clear? Now which method will be applied? Try first. What is the answer? First of all, what we'll do in such kind of problem, because I know if I divide that number by 35 and they are asking find the least number, it means there are infinite numbers which satisfy this property, but I am going for the least number. So first step, what will I do? I'll take the LCM of 35, 56, and 91. If I take the LCM of these, then what will happen? Okay, let me explain with the simple thing. Let's say if I have 2, 4, and 8. Let me take the LCM of 2, 4, and 6. What is the LCM of this? What is the full form of LCM? Least common multiple. It means that is the least number which is divisible by 2, 4, and 6. Is it clear? So similar way, okay, or let me do this thing. 8 and 3. Okay. What is the LCM of 8, 3? 24. Clear? 8 into 3, 24. So what can you say about 24? You can say 24 is the least number which is divisible by 8. At the same time, it is divisible by 3 also. There is no less number than 24 which is divisible by 8 and 3 simultaneously. Is it clear? So similar way, LCM will give me that number which is divisible by 35, 56, and 91 also, right? Is it clear? So first step will find the LCM of 35, 56, and 91. How to find the LCM? Prime factorization. So 35. 35, how, what can I write? What is the LCM? No. No. LCM, how to find? You see, how do I find the LCM of 8 and 3? 8, how you can write 2 power 3 into 1, and then 3 is 3. Is there any common factor? No. If there is no common factor, I'll multiply all of them. Right? This is how we find the. So 35, what will I write? 5 into 7. 56, what will I write? I'll write 2 power 3, 8 into 7. 91, what will I write? 7 into 13. Is there any common factor between them? 7. So 7 I'll write only once. So 7 into 2 power 3 into 5 into 13. So you have to multiply all of them. 3640, right? So this is the LCM. So I can say this is the least number which is reached by 35, 56, 91. But that is not our answer, because what we need, we have to add. Is it clear? I can say, let's say 8 is reduced by 2. What? 8 is reduced by 2. So what will happen? Remainder is 0. Let's say here I want remainder. Let's say here I want remainder as 1. Then what I have to do? Add 1. So similar way, this number 3640 is divisible by 35 also, 56 also, and 91 also. Clear? So here I can say, if I divide, the remainder is 0, but what I need? Remainder at 7. So what will I do? Add 7. So what is the correct answer? 3647. Is it clear? Okay. Let's try one more problem. Here the question will be, here I am giving the remainder as same, but this time remainder will be different. This one is clear to everyone? Here CRT won't work, but using the number theory we can find out. Clear? Any doubt? This one is clear, right? Okay. Next problem, all of you write. Find least number, find the smallest number when divided by, find the least number when divided by 28, 32. Find the least number when divided by 28, 32, leaves the remainder 8 and 12 respectively. Find the least number when divided by 28, 32, leaves the remainder 8, 12. Let's see how we can solve the problem. So first of all, what will you do? First step, finding the LCM, right? Because least number means, least means always LCM. So first of all, I'll find the LCM of 28 and 32. This is, I think, 7 into 4. This is 8 into 4. What is the common? 4. So this will give me 4 into 7 into 8. Now what is the answer? 224. But 224 cannot be our answer, because we need this remainder 8 and 12. But this time we are expecting the different remainder. It means that any number x when divided by 18, 28, remainder should be 8. That number divided by 32, remainder should be 12. If both were supposed to leave the same remainder, then in that case, what we would have done? We can simply add the remainder. But this time we cannot do. If you add 8 into this, then this condition will follow, this condition will fail. If you add 12, then what will happen? This condition will follow and this condition will fail. Now how can we solve? 8 to 12, what is the LCM? All of you try. You are telling add LCM of 8 and 12. What is the LCM of 8? 24. You add 24 to 28. Now you try divide 240 to 248, right? Now you divide that number by 28 and let's check you are getting 8. You won't get it. 8 into? Yeah, that's what you are supposed to do. You see? Yeah. Then what we do here, you see? What is the difference between 28 and 8? 10. What is the difference between 32 and 12? 20. Sorry. This difference is 20. This difference is also 20. So if you add this difference, then only it will work. Because you see, 20 divided by 8, then what happens? 20 divided by 28, remainder is 8. Can I say? If I write something like this, 20 mod 28. So 28 minus 20, I can write 8, because that's what we do, right? Whenever we have to small the number, so 28 minus 20. So similar way, what I have to do is, I have to, here because I have 8, the difference between 28 and 8 is what? 20. Difference between 32 and 12 is what? 20. So I have got two options. First I try with adding. If you add these numbers, this is not working because here we have different number. Next step, what will I do? I'll try with the difference. So from the given number, I'll subtract the 20. When you are supposed to subtract, first of all, you try the adding. If you are getting the same number, then what will happen? Then if both numbers are same, then this method works. In next method, what will you do? You'll subtract this from this and add. I'll explain why this method works. Let's say this number is 224, any number. So you can say that x is nothing but 28 times some quotient plus remainder. This is what you need, right? X 28 times quotient plus 8. But this time you see 224 is there, but you see 224, but you need 8 because if you have 224, this won't work. But what you do, if you subtract both side 20, then you see, are you getting 8? Here you will get 12, right? Are you getting my point? The thing is, if you are adding to this, if you are adding to this number, if both numbers are same, then that method work. If you are not, then what you do? You 28 minus 8, you add 20. Then what happens? This number will definitely leave the remainder 8 because rest of the numbers you can mix it here. Are you getting my point? Rest of the numbers you can mix it here and remaining will be get it here. So it means we have learned two concepts. If you are dividing and let's say A, B and C, you are dividing by some number is there, X, you are dividing by A, B and C, all are leaving the same remainder. Then what will be our answer? LCM of A, B, C plus R, first thing. Next say we have A, B, C and maybe 3 number or maybe 2 number. Then what will happen? Let's say 2 numbers is there, some number is there, and let's say if I'm dividing by A, then I'm getting capital A, here I'm getting capital B. So what will I do? In this case, my answer will be LCM of A comma B, subtraction of A minus A, because this is what I have to subtract. Is it clear? Both are clear, right? This one when will you use? When remainder is same. This one when will you use? When the remainder is different. Is it clear? Next we'll see crypt arithmetic problem. This is little different kind of problem related to coding decoding only, but this is little different. So crypt arithmetic problem is what? We can say it is different type of problem, but we have some constraint. If I ask you, solve this x plus y equal to 2 such that x and y are natural numbers. Can you solve this value? Solve x and y are natural numbers. What is the possible values of x and y such that it will give 2? Only one possibility. So similar way we have some constraint. We will be given the equation and you have to solve it. So, but before we move to the crypt arithmetic problem, I'll give the logic. First step is you will be having alphabet A to Z. A you can here you forget about rank and all. Each letter you can assign the number from 0 to 9. First step. Is it clear? Each letter you can assign the number 0 to 9. First step. Second step. Yes. Yeah. Next step is no two letter will have same assignment. Are you getting my point? It means we cannot, let's say I'm assigning A is equal to 0. Now remaining number cannot have the 0. Is it clear? Third step is sum should be given, sum should match the given. Sum should, whatever the sum we are getting, sum should match with the given data. So 3 problems we have. First one is we'll have letter A to Z. Each letter I can assign a 0 to 9. This is different type problem that is called the crypt arithmetic problem. So first step is forget about rank and all. Each letter I can assign from 0 to 9. Next is no two letter will have same assignment. Let's say if I'm assigning A equal to 0. Now remaining letters I cannot assign is equal to 0. So let's start with simple problem. If I ask you TO, here I have GO. 2 plus go is equal to out. Now the thing is you have to find the value of T, O, G, T and U such that this condition satisfy. So what will you do? All you know T, G, O all are from 0 to 9 only, right? So first of all you have to find the value of O, G, O, T, everything. So first of all tell me what is the value of O. How can we decide? You see all are O. This one is O, all are 0. O. Okay. So first of all, what is this value of O? So we can say maximum T can have 9 because assignment is 0 to 9 only. This can be 9. This will maximum, this can have 8 because if this I am assigning at 9, then this cannot be 9. It means 9 plus 8, 17. Yes. Maximum, this value of O can be 1 only. It cannot go more than 1. It definitely, from here we have got O is equal to 1. Is it clear? If this is 1, so what will I do is, I'll write this is T1, G1, and here I'll get T, this is 1, and U. First of all, T, T1 plus 1 is 2. So T is 2. 2. Now tell me what is the value of G? G, can I take G7? No. If I take 7, then 7 plus 2, 9. Then carry won't come. Then I have got two options. I got two options. Either I can take 9 or I can take, either I can take 8 or 9 also I can take. Then 9 you take, you see, that's why I'm telling the problem. For G you have two options, 8 and 9. If you take 8, then what will happen? 102. All letters got the unique value. You see, O is corresponding to 1, T is corresponding to 2, U is corresponding to 0. Now I'll tell you what is the problem if you take 9. You see, if you take the 9, 1. So U is also having assigned digit 1 and O is also having assigned 1. So this is not possible. So this is false. This one is correct. Is it clear? So all of you got the idea how do we solve the crypt arithmetic problem? First of all, we start with the leftmost digit. You say maximum value of T can be 9. Maximum value of G can be 8. If this is 9, then definitely this cannot be 9. So 9 plus 8 means 17. So definitely in crypt arithmetic problem, this digit, leftmost digit will always be 1, no matter what you do. Is it clear? Now I'll give one more problem. Let's say you can do it. What? Yeah, logic will be same. In all crypt arithmetic, yeah, values will be 0 to 9. No, no, no. This time it will change. According to, or definitely whatever is coming here, leftmost digit will be 1. So I'll give one more problem. Let's say, let's try. Let's try with simple problem. A, B, B, C, C, and here you have A, B, C. Now all of you try. A, B, C. Definitely, yeah. A is 1, so definitely 1, 1. That's fine. Because this maximum, this can be 9, this can be 8, this can be 7. 9 plus 8. You know, because this, if this is 9, this will be 8, this will be 7, right? Maximum I'm talking about. So what is the, yeah, to try, that's what I'm asking. Try to solve this one. A, B, B, C, C. What is the value of A, B, and C? This is the crypt arithmetic problem. It means A, B, C all will have value from 0 to 9. Is it clear? Next thing is what? Next thing is, if you are assigning A, okay, all of you try this one. Is D, T, H, I, S. Here, H, E, R, E. All of you try to solve this. What is the possible value of I, S? This is I, S. Here 2 digits are left. Nothing is there. Then T, H, I, S. Here you have H, E, R, E. Try to solve this. Definitely S and N. If this and this both has to be same. Try to solve this one. How? What is the possible value of S? You can say 1 is also possible. You try 1 plus 1, 2. Then here if 2 is coming, here you have to put 2 here also. Try to solve what will the possible value of S. T and H. No, both won't. No, what I told is each letter will have the different assignment. If you are assigning S as 5, then 5 plus 5, 10. Then if this is 0, 1 will be carried. So likewise you have to solve it. T and H cannot be same, na? If this H and definitely this H will be same. But here you have to choose the number which will satisfy. In simple words, if I put, you have to select the numbers 0 to 9 such that all are different and satisfy this condition. That's all. Try to solve this condition. Is this question clear to everyone? Question saying is, is plus this equal to this one. It means all digits are different. If you are assigning s is 5, then 5 plus 5, e becomes automatically 0. Now rest of the letters should not be assigned as 5. That's the only problem. So from here you can say that s plus s, only two options is there. Either e will come, right? Either e will come, or what will happen? S plus s is equal to e plus 10. You see, if I'm taking 1, so 1 plus 1, 2. 6, 1 second, tell me. This one? 8, 9, 8, 9, 6, 5. So final answer? 9, 0, 9, 0, 3, 0. See, is it clear? Is there any number repeating? 5, 5, 0, 5, 5, 10, 1, 6, 7, 13, 1, 9, 0, 1, 8, 9. This is also same. So what you can do is, so you can apply this method. So actually logically you solve, what will happen is s plus s equal to e. So if you have solved this, you can try this one also. Let's try this one. Send plus more money. All of you try this one. And those who haven't got, listen this one. S plus S equal to E. So it means either it will have carry or it will not have carry. So we can start with 0. We can start with 0. First step, 0 plus 0, 0. Not possible, because if you take 0, then this 0 is coming. 0 is not possible. We'll remove that. We'll take 1. If you take 1 here, then what will happen? 1 plus 1, 2 will come here, right? If 2 is coming here, then how we have got 2? 1 carry should be there. You see here, if I am taking 1, so this 1 plus 1 will be 2. If this is 2, then this has to be 2. If this is 2, then definitely I will say some value r will have some carry. So if this 2 is coming, then either h will be 2 or h will be 1 only. Only two possibilities, right? If h is 1, that we cannot take. Because h we have already taken s as 1. It means that 2 is also neglected. Now we'll try for 3. So likewise, we have to try for the cases. You see, if you first of all tell me s equal to 0 is accepted or not? Not accepted. 0 plus 0, e will be 0. S equal to 1 is accepted or not? Not accepted. If you take 1 plus 1, this will be 2. This will be 2. Then what is the possibility? If this 2 is coming, then definitely this h has to be either 1 or 2. If this is 1, then 1 carry will be there. 1 we cannot take. 2 also we cannot take. If 2 is this 2 is there, then directly we cannot copy 2, because this 2 and this 2 has to be same. So it means 2 is also rejected. Likewise, you have to try all the combinations. Is it clear? Let's say you can say, sir, 3 will work. So once you have done with this, then you have to move to this I plus r. So you said like I plus r will be either, it will be r, right? If it is r, then definitely it has some carry, because I plus r you are doing, it means that h and e will be equal. So definitely I has to be greater than or equal to 5, because you see, if this is 4, then 4 plus 4 is what? 8. So definitely after, then what will do? You simply copy this number here. So h and e will be equal. That is not acceptable. Is it clear? H and e cannot be equal. It means that I has to be 6. So once you finalize I is 6, here also you have seen it should have some carry. So this will be 5. Now you try. 5 plus 5 is what? 10. 1 plus 6, 7. 7 plus 6, 13. 1 h, 3, and h will come. Now you tell me what will happen here. 3 is coming. So what will the value of h? 2 will come. So therefore definitely 3 will come here. So now here value of t is also there, right? So what will be the value of t and h? H we already know, right? H is 2. Some mistake or it's clear? Let's check. 5 plus 5, 0. 1. 1 plus 6, 7. 7 plus 6, 13. 1. And then, okay, here we have got h and t. Okay, we'll try again. H and t. Here we have got 3. Now you see here, what happens? E, oh, sorry, E is 0, right? This E, this is 0. Now all of you try. If this is 1, we cannot take h equal to 0, because one more digit is there. So we have to add 1 into something such that I get 2-digit number. Only one option is that. So h has to be 9. 1 plus 9 is 10. So definitely 1 will come. So definitely 1 will come. Sorry. Here t will come. 1 will come here. So now what is the extra number left? You see, 1 is the carry and h will come here. And what is the value of h here? H is 9. So how I will get 9? 1 plus 8. So this will be 8. Is it clear? The thing is, these problems are not complicated, but the thing is, you have to try different combinations, right? I'll give one more problem. Let's say, let's take this one, BASC. All of you try this one. BASE BALL, and that is GAMES. Now try. First of all, tell me what is the value of G? 1, right? Definitely. Because if maximum, let's say this is 9 and this 9. 9 and 18. So definitely G is 1. So likewise, all of you try. So definitely value of G has to be 1 because maximum, let's say in worst case, G is 9. So 9 plus 9, 18. So this will be 1. You know the value of G. Now you try. How G can be 2? Tell me. G, maybe anything. You see. B, what is the maximum value of B? 9. This one, 9. 9 plus 9. So what will come here? 1. Maximum. Because even if you take maximum, then also it will be 1. So G will be 1. So very good. G, we have got 1. Now, what first of then G we know. So from here we'll find. If G is 1, definitely B and B will choose such a way it should have some carry. So definitely from here I can say B has to be greater than or equal to 5. Are you getting my point? If you take 4 plus 4, 8, then G won't come. So B has to be greater than or equal to 5. Next, we can say, from here you see, I have only two conditions. E plus L equal to S plus 10. Because that's why I'm getting 4 digit plus 4 digit, 5 digit. It means this will have some carry. First thing, is it clear? E plus L equal to S plus 10. Why S plus 10? Because even S is coming, then it will have some carry. Is it clear? Next, can I say S plus L equal to E? S plus L equal to E. So from here, can you find the value of E here? L here? These two equations, can you find the value of L? 5. L equal to 5. Why? Because you see S plus L equal to E. So what you'll do? You substitute the value of E here. So what happens? S plus L equal to S plus 10. So S will get cancelled. So 2L equal to 10. So what is the value of L? 5. So from here you got L equal to 5. So you write BASE. Here you will get 5. Here 5. And already you know the value of G. Now to tell me what is the value of leftover thing. B. Here we have S, E, M, A. Now you tell me what is the value of S then? S. This one is S. Definitely 3. If this is 5, you see L is 5. If L is 5, or you can see if L is 5, then E plus L has to be S, and S plus L has to be E. Now all of you try. How can you solve? L is 5, then what is the value of E? You put L equal to 5 here, so you'll get E minus S equal to 5. S E equal to E is 6, not E is 3. Definitely. How come? You see, instead of L you put 5, so you'll get E plus 5 equal to S plus 10, right? So from here E minus S equal to 5, right? This one is clear. Instead of L you put 5. If you put 5, then you'll get E minus S equal to 5. Oh, okay. The difference between E and S is 5. It means the difference between E and S should be 5. And this one is already 5. And this one has to be 8 and 3. You see, this one is 5. And if this is 3, definitely this will be 8 then. Right? You see, this is difference between this and this has to be 5. How is it possible? Because here we are adding 5 also. If difference has to be 5, if this is 1, then this has to be 6. 6. Then all difference. If this is 3, the 1 we cannot take because 1 we are assigning to G. So that is rejected. So 3 plus 5 is 8. Okay. 6 plus 5, then 11. Okay, you take 6. Okay. Okay. E you are telling you can take 6. Okay, then 6 plus 5, this one 11. Then 1 carry will be there. Then 1 plus 1, 2. 2 plus 5, 7. You see different result. E cannot have 7, it means that is rejected. So it 4 also try this different. Are you getting my point? You first you try start with 1. We cannot take 1. Rejected already because G is having. If you take 4 also, then same problem. Because this E and this E has to be same. So it means we'll take this 3. This is 5. Now what will happen? This L is 5. This is 8. 3 plus 5, 8. Then what will happen? S is already 8. 8 plus 5 is what? 13. So this 3. This has to be 1. Now you tell me what is the value of A? Definitely, this if this is 4, 4 plus 4, 8. 8 plus 1, 9. So definitely 4 and 4. Now what is the value of A? B. B 7. Because what we are left with? Because 1 we already used, 2 we haven't used. If we use 2, not possible. Because then last carry won't come. 3, 4, 5, 6, 5 already used. Only possibility is 6. If we use the 6, then what will happen? Can we use the 6? No. 6 if you use, this will become 2, but we need 4. It means only possibility left with is 7. So 7 plus 7, 14. So this will be 4 and this will be 1. So what is the final answer? Let me write 7 4 8 3 7 4 5 5. And what is the final answer? 14938. So this is our final answer. Okay. So in assignment also you'll get lots of problem. The only thing is you have to you see how many numbers are there? 0 to 9. So you have to try different combination. And some of the cases you can reject. Let's say we started with 2. We can say we cannot take 1 because 1 is already assigned. So likewise you have to eliminate the cases. Such kind of problems are little tricky, but it's not like impossible you can't do. It may take some time because if you are taking E is 1, then you say E1 is rejected. Then you take 2, you start doing something 2 plus 5, 7, then 7 plus 5, 12. Then you see both are different. It means 2 is also rejected. Then you think about 3, maybe 3 is assigned to something else. 3 is not possible. Then you have 0 to 9 only. Likewise, you can do it. Clear? Okay. Yes. You see, here only two possibilities are there. Either E plus L equal to S. It means single digit, no carry is there. But you see, E plus L is equal to S if I am considering, then S plus L is equal to E. That is not possible because this S is the sum of these two. Then S, if I am adding L, how can I get E? Only one digit number. It means only S plus 10 is only possible. You see, if I am considering this, we want to give me the carry. Let's say this is 1 and this is 2 if I am getting 3. If I add something into 3, will I get 1? Never. Because number are from 1 to 9 only. Clear? So that's all about today's session. And I'll just give the assignment.